today we have major problem given some numbers like n, k, n is up to 10, k is up to 100. We want to build a string. The string contains the characters A, B, C, and they shouldn't be repeated in adjacent manner. So this is AA disallowed, AB disallowed, and CC disallowed. And valid strings are like A, AC, ABA, and so on. Now, given this problem is small, we have that the maximum length of the string is n, 10, so 10 characters like 2, 3, 4, 5, 6, 7, 8, 9, 10, and we want to sort them, alphabetically, so like ABC, and then we want to find the case value. So this is like if the strings are ABA, then ABC, so and then ACA, and the k is equal to, we want to return this ABC. Now, given this problem is a small problem, the fastest solution, the fastest that came in your mind is the brute force backtracking, depth first search, backtrack. The backtrack means you don't have to do any some memorization, you don't have to keep the values also, but you can. So just use some placeholder of 10 values and do depth first search of position. This position is what the value you place in this placeholder, this I position. And inside the first search, just check if we at the first position use ABC as starting point, all values, and if you're not at first position, then remove the letter that was the previous one. So this will be placeholder I-1, and placeholder will always be containing the previous value. It will be like A, B, C, and then A, like C, and then A, and so on. Now let's look at this accepted solution. So I don't spend much time on it. I spent 11 minutes. I use the character array. Position I collect all the strings at the finish line, sort, and then take the case value. The k is 1 based, so keep in mind. And this is not effective solution, it is slow, and there is some interesting insight we can derive from this solution. So given that we iterating over ABC in alphabetic order, that means our resultant strings are all already sorted. So the first inside, the default depth first search is sorted order already, because we're iterating by A, B, C letters one by one. That means we can remove this collection, remove the sort at least, and also remove the collection and just use some counter that will count until it reaches the k value. And it would be like optimal by memory, not very optimal by speed, however. Let's find what is the time complexity for this, what is the speed of the solution. Initial is abc. After that we're going from A, we're looking for BC, from B we're looking at AC, and from C we're looking for AB. So each time the first is split by 3 subtrees, and then each subtree have split by 2 children, and so on. So from A it is always BC, from C it is always AB, from B it is always AC, and from C it is always AB. And that means the total depth of our tree, or the height, is 2. It is n, and the total number of each elements of each subtree is 2 to the power n minus 1. N minus 1 because the first split was not 2, it was 3. So it's kind of A starts a tree of 2 to the power n minus 1, B starts a subtree that has also 2 to the power n minus 1, and C starts a subtree that also has 2 to the power n minus 1 values or nodes. Now, given that we already, so the time complexity is O of 2 to the power of n, the first split we are not, doesn't change the O notation. However, we can now derive the math solution. So if we have kth position, we know that we can find which character would be the first. Why? How can we do this? Because this is all equally split by 3. The first entire tree split by 3, and we just check which, so it is kind of 2 to the power n minus 1, 2 to the power n minus 1, 2 to the power n minus 1, and the k is somewhere here. We know how many elements would be total, and we know how many elements at each bucket. And each this bucket is A, this bucket is B, and this bucket is C. So this is how we find the first character. Just take the size of this tree, so 2 to the power n minus 1, and you use it as bucket size, and then do this as k divided by the bucket size would give us the index of it's 0, 1, or 2. If the case should be however 0 based, so we're doing k minus 1 at start, and after the initial split we added the subproblem of division by 2, so we have 2 to the power n minus 2 sub 3 and 2 to the power n minus 2 sub 3. So this is kind of each bracket. So for example, A have this for B and for C, and again our k after the split should be adjusted, so it is k percent bucket size, and the bucket was 2 to the power n minus 1. So this is how you find the index. The index is 0, 1. And this is a math solution, and it allows us to find in O of n, because we each time we do n minus 2, n minus 3, and so on. Let's look at the code. So I use this. This is a simple version of this code. So I use B for the bucket. It is 1 shell n minus 1. I do this change of k minus 1 to make it 0 based. Then I use the initial split for the 3 values a, b, c, and the index is k divided by the bucket size. I also check that it's not out of bounds, and if it's out of bounds I return empty string. And then I repeat this for until we have 2 to n loop, and I do this adjustment of k. It is modular division by bucket size, and then the bucket size is shrink by 2, because each time we split by 2. Then the chapter is I use a replace hack to remove used previous chapter, and this is index k divided by bucket. So it's always like this. So this is solution, math solution O of n. Now I rewrote it to the recursive version, and it's kind of funny. So yes, the idea is the same. I just take as argument for the first one, it would be abc. Kotlin allows us to get put in the default, and after that I use this abc minus replaced previous chapter, and this chapter is what I add and at current step. So the idea is absolutely the same. And now let's look at the Rust code. It's always funny how we can make absolutely crazy solutions, and this is one. just use the fold to build all the strings, starting with empty, and then we do a fold and flat map to this is a vector of all the strings, and we are filling them one character at a time, simultaneously in parallel. So with each string, we take the abc, remove the character that has already ends, and add them character at the end of each string. So each will be plus 2 positions each time, and it kind of fills it in. It starts with empty, then it is abc, and then it is 2 letters. So it's kind of build-up solution. Then it is a b c, then it is a b a c b a b c c a c b. This is how it fills it up. So a nice one liner. However, the Rust is even more crazy, and we can use iter tools, and this solution is just a single method invocation, multi-Cartesian product, and it generates all possible permutations for the length of n. And then I filter it out, and then I convert them to string. So this solution is 20 milliseconds, and when I wrote the solution that was like generating only the necessary strings, it was slower, 21 milliseconds. So it's kind of very optimized version, the multi-Cartesian product. Very, very cool. So that's it for today.